Yeah, it does. I just don't know if it'll make a cute movie. But, okay, so when you have a carbon-carbon, or when you have a chiral-carbon, and you want to deal with, let's say I have a double bond, an OH, a CH3, and let's make it a carbon-oxygen double bond. So if I'm ranking these number 1 to number 4, what's number 1? The OH is definitely number 1. Then I got carbon versus carbon versus carbon, so they're all tied. Carbon with the 3 hydrogens, everything's going to be higher than that. So that's going to make the carbon with the 3 hydrogens number 4. So the question is, C8, how do we handle the double bonds? So what we have to do is write the equivalent structures. So that's where we would take, for instance, this carbon, hydrogen attached, it's got a CH2 attached to it. So let's write all the single bonds for that CH double bond, CH2, except no double bond. So now I'm going to replace this carbon-carbon double bond from this carbon's perspective right here. I'm going to look at the double bond from that carbon's perspective, which means I need to give it 2 carbon-carbon single bonds. So the CC double bond gets, that CC double bond is going to get 2 CC single bonds. The first CC single bond is here. The second CC single bond will be there. So then we have to look at it from this carbon's perspective and say, okay, how's that going to work? Well, that carbon's now going to get 2 CC single bonds. This one right here is the first CC single bond, and then it gets the second one. So ideally at the end of this, what the carbons had only 3 bonds. I can't compare those, so now I've got them compared at 4. So now I can go ahead and compare this carbon to, for instance, this carbon over here. And that's why the CH3 is going to be number 4. Up here, I would do the same thing. So I'm going to have a C, an O, and an H. I'm going to now replace the carbon-oxygen double bond with 2 CO single bonds. So here's the first CO single bond, here's the second CO single bond. But then I have to replace this OC double bond with 2 OC single bonds. And so it looks like that. So these are what were called the equivalent structures. So now I can compare this carbon to this one. This carbon has what? 2 C's and an H attached to it. What does this one have? 2 O's and an H. Which one wins? That's number 1. That's number 2. That's number 2, that's number 3, and that's number 4. So that's what we would do to handle the equivalent structures. Does that help?